Welcome to the deep dive. This is where we take source material that you've provided and, well, we cut right to the chase, the essential knowledge, the core insights you need.
Exactly. No fluff, just the good stuff.
And the material for this dive is pretty exciting. AI Engineering Building Applications with Foundation Models by Huyen.
Oh, yeah, a really significant book. And we've got some strong endorsements here, too. Vittorio Cretella, former global CIO at P&G. Mars, he calls it, a must-read.
High praise indeed.
And another reviewer points out Chip's, real-world chops and actually deploying AI. That's key. So our mission today is to really unpack the fundamentals of AI engineering as Chip lays them out.
Absolutely. And one thing the book stresses right off the bat is, okay, some principles might seem familiar from, traditional machine learning.
Right, there's overlap.
But these new foundation models, they're just different.
Yeah.
The scale, the power, it opens up totally new possibilities.
And new challenges, too, crucially. These aren't just bigger versions of old models. They need novel solutions, fresh thinking.
That's a great way to put it. It's really an evolution, isn't it?
Definitely. And the book, it walks you through that whole life cycle. Taking a foundation model and actually adapting it, making it work for a specific real-world problem.
Using established practices, but also
the brand new stuff, techniques specifically designed for these very different kinds of models.
And I think what's immediately useful for you, listener, trying to get a handle on this, is how the book tackles those first big questions.
Yeah, the really practical ones, like, do we actually need this application? Is AI even the right tool here?
Or, the classic build versus buy decision, but for AI. Do I start from zero or leverage existing models?
Exactly. And it helps that the book includes actual examples, success stories. It makes it tangible, what's possible.
It really does. Now, the book also suggests, even if you're not an ML guru, it pays to understand a bit about what's under the hood. Right?
Oh, absolutely. Knowing about the training data, the model architecture, how it's aligned to human preferences, even how it generates responses.
It gives you an edge.
It gives you a definite edge in getting the best performance. Even seemingly small things, like the generation settings you choose, they can make a huge difference to the output quality.
Okay, let's maybe zoom in on that term, foundation models.
Yeah.
My first thought goes to language text.
That's where it started, for sure. Large language models, LLMs, they were the breakthrough.
But it's broader now.
Much broader. The concept covers models trained on images, video, audio, other data types. Think GPT-4v, Claude 3, they handle visuals and text.
Right, multimodal.
Precisely. And adding more modalities like that, it just massively increases their power and potential uses.
Okay, so for someone wanting to get up to speed fast, what are some of those key application areas the book highlights?
Well, coding assistance is a big one. It's not just auto-completing code anymore.
It's more like context-aware help.
Exactly. It's understanding the intent, suggesting architecturally sound approaches. It's like having a super smart pair programmer really changes the game for developers.
Okay, what else?
Then there's image and video production, generating unique visuals, doing complex edits. It's making creativity more accessible,
Democratizing it, in a way.
Sort of, yeah. And writing and content creation, obviously. Drafting emails, articles, marketing copy.
And education too, right? Personalized learning.
Huge potential there. Imagine lessons adapting to each student's pace. Transformative.
And conversational bots moving way beyond basic chatbots.
Oh, yeah. Much more sophisticated assistants, understanding nuance, holding real conversations.
Then there's dealing with information overload. Aggregation, summarization.
That's massive.
Yeah.
Quickly digesting huge amounts of text, including those Talk to Your Docs apps.
Being able to just ask questions of your documents in natural language, that's power.
Incredibly powerful, makes information so much more accessible for you.
And pulling structured data out of messy sources, like PDF.
Data organization and extraction, yeah. Automating that kind of tedious work.
Which leads into the last one mentioned here, workflow automation.
Right. Taking over repetitive tasks, freeing up people for, the more human stuff, strategy, creativity. It's a really diverse landscape.
It really is. So this deep dive, our goal is to give you that solid grounding in these core ideas from the book, spark some aha moments without getting lost in the weeds.
Exactly. Starting with the basics, like tokens.
Right, the basic unit for language models. And it's not always a whole word, is it?
No, often not. It could be a character, a word, or just part of a word, like the book's example. I can't wait to build AI applications.
GPT-4 breaks that down how?
Into 9 tokens. Can, then T, wait to, build AI applications. Each is a token there.
Interesting. So can't is 3 tokens.
In that case, yeah.
Okay.
And you can actually check this yourself on the OpenAI site, see how different models tokenize things. A neat practical tip.
Definitely helpful. Now, we see these models chatting, but the book draws a line between just completing text and actually having a conversation.
A really important distinction. A base language model is fundamentally a completion engine. It predicts the next token.
So if I give it, say, classify this email, urgent meeting request.
It might complete it with likely important, or maybe category, urgent. It's performing classification via completion.
But that's not dialogue.
No. If you ask a base model a question, it might just try to complete your question with another question, or something nonsensical in a conversational context.
So how do they learn to chat properly?
That's where post-training comes in. Things like instruction tuning, reinforcement learning, basically teaching the model the rules of conversation, how to respond appropriately, take turns, stay on topic.
Got it. Teaching it conversational etiquette, almost.
Yeah.
Now, something else the book really drives home is the sheer scale increase.
Oh, it's mind-boggling. GPT in 2018, 117 million parameters. Seemed huge then.
And then GPT-2.
A year later, 1.5 billion. Suddenly, 117 million looked tiny.
And now, the book mentions the 100 billion as being large. But we know models are even bigger now.
Exactly. It's just exponential growth. And this scaling isn't just bigger numbers. It unlocks emergent abilities, things smaller models just couldn't do.
Like more complex reasoning.
Yeah, or deeper language understanding. It's a key reason why they're so capable now.
And this size, these billions of parameters, they need a matching amount of data.
Right, precisely. A huge model needs a huge, diverse data set to learn effectively. Its learning capacity is massive.
So you can't just train a giant model on a small data set.
Well, you could, but it'd be inefficient. You'd probably get better results with a smaller model trained on that same smaller data set. It's about matching the model capacity to the data richness.
Makes sense. One last point from this overview section that struck me as useful for you, the listener, thinking about applications. They often cross categories, don't they?
Oh, absolutely. Very practical point. An AI app rarely fits neatly into one box.
Like the example of a bot being both a companion and an information source.
Exactly. Or an app that extracts data from a PDF and lets you query that data.
So when you're thinking about building something,
Think multifunctionality. One foundation model might handle several related tasks quite well. Don't feel constrained by narrow categories.
okay, great. So recapping this first part of our dive, you've got a sense of AI engineering via Chip Huyen's book, The Shift from Traditional ML, the core questions, the importance of model internals, tokens, completion versus conversation, the incredible scaling, and this wide range of applications.
Yeah, I think you should have a much clearer view now of just how versatile these foundation models are. They're the building blocks.
And the impact is potentially huge, from education and creativity to, complex business processes.
Truly remarkable potential. But as the book emphasizes, it's still early days in many ways. Lots of active research.
Like understanding the training data better.
Yeah.
It's quality, quantity, diversity.
Absolutely critical. Garbage in, garbage out still applies, maybe even more so at this scale.
And the model architecture itself. The book mentions transformers being dominant.
But also alternatives popping up, like RWKV. People are exploring different ways to build these things.
What are transformers briefly? And RWKV.
Sure. Think of transformers as a really effective way for the AI to weigh the importance of different words in the input text, no matter how far apart they are. It helps understand context better. RWKV is an alternative approach, trying to get similar performance, perhaps more efficiently, especially for very long sequences. It's an ongoing research area.
And then there's scaling, just making them bigger and more efficient, often measured in FLOPs.
Right, the raw compute power. And critically aligning them with what we actually want them to do. Human preferences.
That's the SFT and RLHF stuff. Supervised fine-tuning and reinforcement learning from human feedback.
Exactly. Because they learn from the whole internet, basically, they can pick up biases or generate harmful stuff. Alignment is about steering them towards being helpful, honest, and harmless.
Teaching them good behavior.
Pretty much. Using human feedback to guide their learning after the initial massive training run, it's essential for safety and usability.
Another really interesting aspect is that their output isn't always fixed, is it? It's probabilistic.
That's fundamental. They predict the likelihood of the next token. So there's inherent randomness, or rather variability.
And we can control that variability with things like temperature.
Yeah, temperature, top hay sampling. These are knobs you can turn. Low temperature makes the output more focused, predictable, maybe a bit boring.
High temperature means more creative, potentially more random.
Exactly. More surprising, sometimes less coherent. Finding the right balance depends on the application. You need to account for this probabilistic nature when you build things.
And for many uses, you need structured output, like JSON or a table. Getting the AI to reliably produce that format is still a challenge.
It is, though models are getting much better. The book covers techniques like clever prompting, cleaning up the output afterwards, constrained sampling where you limit the possible tokens, or even fine-tuning specifically on structured data examples.
So multiple ways to nudge it towards structure.
Right. It's an active area of improvement, getting models to follow formatting instructions reliably.
But inherent challenges remain. The book mentions inconsistency and, of course, hallucinations.
Ah, yes, hallucinations, where the model just confidently makes stuff up.
And we don't fully understand why that happens.
There are hypotheses related to how they store and retrieve information or maybe gaps in the training data. But yeah, it's a major research topic, how to minimize them, detect them. It's crucial for trust.
Which really leads us to a final thought to leave you with. We've seen this rapid evolution, this move towards multimodality, text, image, video, audio.
All getting integrated.
So given that pace, that integration, what unexpected applications or maybe unexpected challenges do you see coming just over the horizon as AI engineering keeps charging ahead?
That's the big question, isn't it? What happens when these incredibly powerful multimodal tools become even more widespread and capable? Definitely something to mull over.
Food for thought indeed.